All right, so for this deep dive, you sent us a pretty interesting mix.
Yeah.
We're tackling machine learning,
Yeah.
and you've even included excerpts from a textbook in Chinese.
Uh-huh.
I'm excited to see what we can uncover.
Yeah, it's an intriguing combination of material, blending sort of the technical aspects with maybe a little bit of a broader perspective.
For sure.
Mm.
For sure. Well, let's jump right in. I think when most people hear the term machine learning, they think of algorithms and data.
Yeah.
But how would you define it?
You're right. Algorithms and data are certainly central to it, but I think it's really about enabling computers to improve their performance based on experience, and we represent experience as data.
Okay.
So it's not about hard-coding specific rules. It's more about giving the computer tools to figure things out on its own.
Yeah, and that brings us to this Chinese textbook you sent,
Right.
Malveillante, which literally means, well, machine learning.
Exactly. And what's fascinating is that this book really emphasizes generalization as a key concept.
Yeah.
So it's not enough for a machine learning model to just memorize the data it's given.
Uh-huh.
It needs to be able to apply what it's learned to new data that it's never seen before.
So it's like instead of just regurgitating facts for a test, it needs to actually understand the concept so it can solve new problems.
That's a great analogy.
Yeah.
And that ability to generalize is really what makes machine learning so powerful.
Yeah, for sure. All right, well, I think I'm starting to get the big picture here, but let's back up for a second and make sure we're all on the same page with some of the key terminology.
Okay.
I'm looking at these terms like training data and testing data. What's the distinction?
Well, imagine you're preparing for a big exam, right?
Yeah.
You study the material, you do practice problems, that's your training data.
Okay.
Then you take the actual exam, that's the testing data.
Got it. So you're essentially evaluating how well you've learned the material.
Exactly. And in machine learning, we use that training data to teach the algorithm, and then we use the testing data to see how well it performs on unseen examples.
Makes sense. What about features and labels? Those seem pretty important.
Think of it this way. Imagine you're trying to predict whether a customer will click on an online ad.
Okay.
The features are the pieces of information that we have about that customer, maybe their age, their browsing history, their location, things like that.
Mm-hmm.
The label is whether or not they actually clicked on the ad.
Got it. So the features are like the input and the label is the output you're trying to predict.
Precisely. And in supervised learning, which is one of the main types of machine learning, we provide the algorithm with both the features and the labels during that training process.
Okay, hold on. Supervised learning.
Mm-hmm.
That reminds me, we need to dig into the different types of machine learning. I'm seeing terms like supervised, unsupervised, even reinforcement learning in this material.
You're right. There are several different approaches. In supervised learning, as we just discussed, we give the algorithm labeled data, but in unsupervised learning, we don't provide those labels.
Oh.
The algorithm has to find patterns and structure in the data on its own.
It's like being given a box of puzzle pieces, but without the picture on the box and having to figure out how they fit together.
That's a great way to put it. Unsupervised learning is all about uncovering these hidden relationships and structures within the data. And then there's reinforcement learning, which is kind of like training a pet.
Uh-huh.
You reward desired behaviors and you discourage undesired ones, and the algorithm learns through trial and error.
There's so many different approaches.
Yeah.
It sounds like machine learning has come a long way. But how did we even get here? What's the backstory?
It's been a fascinating journey, actually. Early AI research really focused on symbolic reasoning and expert systems, where humans tried to program specific rules into computers.
Oh.
But these approaches were really limited. They couldn't handle the complexity of the real world.
So there had to be a different approach.
Right. And that's where the idea of machines learning from data came in.
Okay.
Instead of hard-coding rules, we give the machine data and let it figure out the patterns in the rules itself. This led to the development of early machine learning algorithms like decision trees and neural networks.
I've heard of neural networks. They're modeled after the human brain, right?
Exactly. They're made up of these interconnected nodes, kind of like neurons.
Okay.
And the connections between those nodes have weights that can be adjusted during the learning process.
Ah.
And these neural networks have been particularly successful in recent years, thanks to the rise of deep learning.
Oh, deep learning. What makes that different from regular neural networks?
Deep learning is essentially neural networks on steroids.
Okay.
With the explosion of data and computing power, we can now build these incredibly complex neural networks with many layers, hence the deep.
I'm starting to see why this field is so exciting.
Yeah.
So we've got these powerful neural networks, but how do they adjust those connection weights to make accurate predictions?
The key is a process called backpropagation. It's a way of calculating how much each connection contributed to the error the network makes. And this allows the network to make very targeted adjustments to improve its performance.
Backpropagation. I'm sensing a future deep dive just on that topic.
Definitely.
But before we get lost in the weeds, I think it's time to take a step back and look at the bigger picture. How is machine learning actually being used in the real world?
Yo, the applications are incredibly diverse. I mean, it's being used in spam filtering, personalized recommendations on platforms like Netflix and Amazon Medical Diagnosis.
Wow.
Pretty much any field where you have data machine learning can be applied to find insights and make predictions.
And speaking of real-world applications, this Chinese textbook mentions a particularly interesting example, Obama's 2012 presidential campaign.
Right. They discuss how his campaign actually used machine learning for targeted advertising.
Wow.
They were able to analyze voter data to identify specific demographics and tailor their messages to resonate with different groups.
So machine learning played a role in a presidential election. That's amazing.
It
It
is.
sounds like machine learning is already having a huge impact on our world.
Yeah, it is.
But I'm guessing there's a lot more to uncover, right?
Absolutely. We've only just scratched the surface.
Sure.
In the next part of our deep dive, we'll explore some of the more advanced concepts in machine learning, like different neural network architectures and the challenges of overfitting.
Sounds good to me.
Yeah. Should we,
Let's take a quick break and we'll be right back with more machine learning insights.
Okay.
All right, we're back and ready to dive deeper into the world of machine learning. We've covered the basics, but now I'm curious about some of the more advanced concepts.
Okay.
You mentioned neural network architectures before the break. What exactly does that mean?
Well, just like buildings can have different architectures, skyscrapers, bungalows, cathedrals.
Right.
Neural networks can also be designed in different ways, each with its own strengths and weaknesses.
So it's not just one size fits all when it comes to neural networks.
Not at all. For example, there are convolutional neural networks, or CNNs, that are particularly good at image recognition. They use a special kind of layer that's inspired by the visual cortex of the brain.
So they're literally mimicking how our brains process visual information.
In a way, yes. And then there are recurrent neural networks, or RNNs,
Okay.
which are designed to process sequences of data, like text or time series. They have these feedback loops that allow them to kind of remember previous inputs,
Interesting.
which is essential for understanding language and predicting future events.
It's incredible how these networks are designed to tackle specific types of problems.
Yeah.
But you also mentioned the challenge of overfitting earlier. What is that and why is it a problem?
Overfitting is when a model learns the training data too well.
Okay.
It's like a student who memorizes the answers to all the practice problems, but can't solve anything new on the actual test.
Oh, I see. So the model becomes too specialized to the training data and can't generalize to new examples.
Exactly. It's a common problem in machine learning, especially when you have a limited amount of training data.
So how do you prevent overfitting?
There are several techniques. One is called regularization,
Okay.
which essentially adds a penalty to the model's complexity. It's like telling the student, yes, you got all the practice problems, right? But you used a really convoluted method. Try to find a simpler solution.
So you're encouraging the model to find a more general solution that's less likely to overfit.
Precisely. Another technique is called early stopping,
Okay.
where you monitor the model's performance on a separate validation set, and you stop training when the performance starts to decline.
So you're basically preventing the model from memorizing the training data too well.
Right. It's all about finding that right balance between fitting the training data and generalizing to new data.
This is fascinating how much thought and nuance goes into designing and training these machine learning models.
It is.
But this Chinese textbook you sent, it goes beyond the purely technical aspects. It also touches on how machine learning can help us understand our own brains.
It's a really intriguing idea. One example they discuss is a computational model of memory called sparse distributed memory, or SDM.
I've never heard of that. What is it?
Well, it's a model that stores information in a distributed way, kind of like how memories are stored in our brains.
Okay.
It wasn't actually intended to directly mimic the brain, but it turns out that the brain uses some similar principles for processing information.
So by studying how machines learn, we can gain insights into our own cognitive processes.
Exactly. It's a fascinating area of research where computer science and neuroscience intersect.
It seems like we've only just begun to explore the potential of machine learning. What are some of the areas where you see the most exciting developments happening right now?
One area that's really taking off is natural language processing, or NLP.
Okay.
We're seeing incredible progress in machine translation, text summarization, even conversational AI.
So we're talking about machines that can understand and generate human language.
Precisely, and this has huge implications for everything from communication to education to entertainment.
What about other areas? Where else is machine learning making a big impact?
Another area is computer vision, which is all about enabling machines to see and understand images and videos.
Okay.
This is being applied in self-driving cars, medical imaging, even security systems.
Wow. It sounds like machine learning is poised to revolutionize so many aspects of our lives.
It definitely has the potential to do so, but it's important to remember that machine learning is a tool. And like any tool, it can be used for good or for ill.
That's a good point. It's not just about the technical capabilities, it's also about the ethical and societal implications. We need to be thoughtful about how we develop and deploy this technology.
Absolutely. As machine learning becomes more powerful and more pervasive, we need to ensure that it's used responsibly and for the benefit of humanity.
It seems like we've covered a lot of ground in this deep dive.
We have.
We've explored the different types of machine learning, delved into the intricacies of neural networks, and even touched on the philosophical implications.
Yeah, and we've seen how machine learning is being applied in a wide range of fields, from politics to healthcare to entertainment.
And I think this brings us to our final thoughts on machine learning. But before we wrap things up, I'd love to hear your perspective on the future of this field. Where do you see machine learning going in the next few years?
Well, I think we're just scratching the surface of what's possible with machine learning. As data becomes even more abundant and computing power continues to grow, we're going to see even more sophisticated algorithms and applications.
So what specific advancements are you most excited about?
One area I'm particularly interested in is the development of machines that can not only analyze data, but also understand its meaning and context.
You mean machines that can truly comprehend information the way humans do?
Exactly. Imagine a machine that can read a news article and not just identify the key facts, but also grasp the nuances, the underlying themes, even the emotional tone.
That would be a game changer. We could ask a machine to summarize a complex legal case, explain a scientific breakthrough, or even analyze a novel for its deeper meaning.
Precisely. And think about the implications for research education, even creative endeavors. Machines could collaborate with humans on a whole new level, helping us to understand and solve complex problems in ways we can't even imagine today.
But there's a flip side to every coin. What about the potential downsides?
Well, if machines can understand data at that level, they could also potentially manipulate it or even generate entirely new data that's indistinguishable from the real thing. This raises concerns about misinformation, propaganda, deepfakes, all sorts of things that could erode trust in information and even destabilize society.
So it's not just about the technical capabilities, it's about the social and ethical implications.
Okay.
We need to be thinking about these questions now before this technology advances even further.
Absolutely. We need to develop guidelines, regulations, ethical frameworks for how we develop and deploy these incredibly powerful technologies. It's not just a matter for computer scientists and engineers, it's a societal conversation that needs to involve everyone.
Because ultimately, the future of machine learning is not just about what machines can do, it's about what we choose to do with them.
Precisely. We have the potential to create a future where machine learning empowers us, expands our knowledge, and helps us to solve the world's most pressing problems. But we also have the responsibility to ensure that this technology is used ethically, thoughtfully, and for the benefit of all humankind.
That's a powerful message to end on. So listener, as you continue your journey into the world of machine learning, we urge you to keep this question in mind. What role will you play in shaping the future of this transformative technology?
We may not have all the answers, but by asking the right questions, engaging in thoughtful discussions, and approaching this technology with both curiosity and caution, we can help to steer machine learning towards a future that benefits us all.
We've covered so much ground already, from the nuts and bolts of algorithms to the potential of machines like actually understanding meaning.
Yeah.
But this Chinese textbook you included, it hints at something else that I found really intriguing. The idea of machines not just analyzing existing data, but actually creating new data?
Yes. It briefly mentions the concept of generative adversarial networks, or GANs for short.
Yeah.
It's a relatively new development in machine learning, but it's already made huge waves.
Okay, I'll admit, the name generative adversarial networks sounds a bit intimidating.
Yeah.
What are they in simple terms?
Imagine two neural networks locked in a kind of competition.
Yep.
One network, the generator, tries to create new data that's indistinguishable from the real thing.
Mhm.
The other network, the discriminator, acts like a judge trying to tell the real data from the fake.
So it's like a constant back and forth with the generator getting better at creating realistic data and the discriminator getting better at spotting the fakes.
Exactly. And as they train against each other, the generator eventually becomes capable of producing incredibly realistic data.
Wow.
Images, music, even text.
This is where my mind starts to reel a bit.
Yeah.
What are the implications of machines being able to create data that's essentially indistinguishable from real data?
It's both exciting and a little unsettling, right? On the one hand, it opens up amazing possibilities in fields like art, design, entertainment.
Yeah.
Imagine machines composing original music, creating photorealistic images from scratch, or even writing entire novels.
It almost sounds like we're on the verge of machines becoming truly creative.
It's a question that's generating a lot of debate, even among machine learning experts.
Yeah.
Are these machines truly creative, or are they just incredibly sophisticated mimics?
That's a deep philosophical question, and maybe one for another deep dive.
Definitely.
But on a more practical level, what about the potential downsides?
Well, the ability to create hyper-realistic fake data raises concerns about misinformation, propaganda, deepfakes.
Right.
All sorts of things that could erode trust in information and even destabilize society.
So it's another example of how we need to be thinking about the ethical implications of machine learning alongside the incredible potential.
Absolutely. We need to be asking ourselves not just what can we do with this technology, but what should we do with it?
Right.
And those are questions that require a broad societal conversation.
You know, going through all this material with you has really driven home the point that machine learning isn't just a technical field.
Mm-hmm.
It's something that's going to touch every aspect of our lives.
Yeah.
You know, from our jobs to our relationships to how we understand the world around us.
I completely agree. And I think this Chinese textbook actually makes an interesting observation about that.
Oh, yeah.
It talks about how machine learning is not just about making machines smarter, it's also about making us smarter.
I like that. How so?
By studying how machines learn, by trying to replicate intelligence in a machine,
Yeah.
we're forced to think more deeply about what intelligence is in the first place.
Oh.
We're challenged to examine our own cognitive processes, our biases, our limitations.
Like holding a mirror up to our own minds.
Exactly. And in that sense, machine learning can be a powerful tool for self-discovery and understanding.
This has been such an eye-opening deep dive.
It has.
We've gone from, the basics of algorithms to the philosophical implications of machines creating art and even, understanding the world.
Yeah.
What a journey.
It's been a pleasure exploring these ideas with you.
Likewise.
And I think the most important takeaway is that this is just the beginning.
Yeah.
The field of machine learning is evolving at an incredible pace, and who knows what amazing and perhaps even unsettling discoveries lie ahead.
So to our listener, as you continue to explore the world of machine learning, remember to keep asking questions. Stay curious and be prepared for a future that's going to be shaped by this incredible technology.
And remember that the future of machine learning isn't predetermined. It's something that we as a society have the power to shape.
That's a great note to end on. Thanks for joining us on this deep dive into machine learning.
My pleasure.
We'll see you next time for another fascinating exploration.